recording. I don't know if we should wait or just skedaddle. Why are people bothering me? One more minute and then we'll start babbling some more. Yeah, well. Interesting that sometimes that minimizes, sometimes it doesn't. All right. Friday. I think it was Friday. I can't remember. I think we did molecular compounds on Friday, which are the ones that are usually fairly straightforward because A, they're all nonmetals. B, the name tells you how many, and the formula also tells you how many of each atom type, and we just use these wonderful things called prefixes for the most part to name things. Oh my gosh. We need to know those. Most of them are fairly straightforward. A monocle has one lens, di, two, tricycle, three, tetrahedron, and the rest are like shapes. So prefix name, ide. The only two kind of exceptions, if the first one is one, we don't write mono because it's redundant. Sometimes you'll see that as the second one. Um, and then AOs and OOs are bad. The other double vowels are okay, so we went through all of those. And I said try 5 or 6, whichever one you would prefer. I'm pretty sure I put answers to all of those in the completed notes. Does anyone have any questions on any of the ones that are in that kind of bit? Or should we just keep on keeping on? I'm going to take the silence as a keep on keeping on. So, the three big types of compounds are ionic compounds, or at least for chemistry 11, which has a bunch of varieties because we have the plain old-fashioned just A group ones. Then we have the transition metal containing ones, which we need Roman numerals for. I guess really I'm going to have to start saying multivalent, but whatever. And then we have the polyatomic ions. All of those come from the front of your periodic table, so you don't, well, the one that we would use, so you don't really have to worry. Then we get into molecular compounds, which are all nonmetals. And in the kind of history of compound types and all of that, Ionic compounds and molecular compounds mainly differ. The big thing is how they behave in water. So a couple hundred years ago, people used to just do everything in water. So you would dissolve an ionic compound. If it dissolved in water, conducted electricity. It had a metal, it fell into ions, yada yada. Molecular compounds, some of them will dissolve in water based on shape and polarity. But if you put a molecular compound in water, because it's not splitting into ions, it doesn't conduct electricity. So we have that kind of bit. Then there was a special kind of type of compound that was all nonmetals for the most part, but when you put it in water, it conducted electricity, which doesn't really fit. So instead of throwing the whole model out. You just add to it. You just add on, well, this group, and it's not a large group, but this group of compounds at the time didn't fit. So, well, we're going to do something. And that is how we came into the idea of acids. So, acids for grade 11, they give a hydrogen ions. You dissolve them in water, you get H pluses. And we're going to talk hopefully about dissolving things in water later. So because of this, they have to have an H and something. Will always be some hydrogen next to an anion. This is all somewhat redundant. So if we have an acid, and we're not talking about all of the crazy stomach or the crazy LSD, blah, blah, blah. We're talking about acidic compounds from grade 9 or 10 or 8. They have a pH of less than 7. They turn litmus red. They tend to be sour. You think of lemon juice or lime juice or orange juice is sour, and that's all because of varying concentrations of citric acid. Your stomach acid, there's acid in your stomach. That's why if you have heartburn or if you are unfortunate enough to throw up, it burns a little bit because that's that acidic bit. Some pops, Coke, Pepsi, any cola has typically phosphoric acid in it, battery acid. There's all sorts of them in everyday life. So naming acids, because all acids have H and something. Well, we can't worry about the H. For us, technically, we need them dissolved in water, which sometimes you're going to see this little AQ sign at the bottom, which means aqueous or dissolved in water. So you take it and throw it in water. Um, but because they all have H's and they kind of form ions, the anion is fundamentally determining the name. So we have three types of anion endings. We have ides, we have eights, and we have ites. Those are the three that come up in terms of general naming of acids. So there's three, whoa, that was kind of weird, sets of rules. And depending on which one, and that's what we have to be able to identify. Is it an ide, of which most come from the periodic table? These ones are always going to be polyatomics. So depending on what it is, we name things different. So we have this bit, the anion attached to hydrogen ends in ide. We put hydro at the front and change the ide to ic, and then put acid at the end. This is where when we get to the big mixture, writing formulas for acids are the ones that I start with because well, they tell you in the name that it's an acid. So if we have HCl, which is hydrogen, Cl, if we ignore the H, is chloride. So if it's chloride, we're going to put hydro at the front. We're going to start with the chlor, and then we're going to change the ide to ic, hydrochloric acid. That is the acid that's in your stomach. And it's probably one of the most common acids in terms of a chemistry lab. You use it all sorts of times. H2S is hydrogen with sulfide. Hydro. Sulfur is one of the, I don't know why, sulfide. This one, we're not going to change it just to hydrosulfic. We're going to put the UR back in, hydrosulfuric acid. The mineral acids, and sometimes these are called because they're from salts of minerals that are in the ground a lot. We're still the same, 8 of you. Hopefully you're all awake and paying attention. So the ides are, you're going to see the halides, fluorine, chlorine, bromine, iodine, sulfur, selenium. Really, those are the big ones you can have. Phosphorus and arsenic, not argon, in terms of the front of your periodic table. But then we have cyanide, hydroxide, sorry, but H with OH, that's not an acid, but cyanide is the other big one. So it's really, those are the ones that are going to have hydro. Then we have the eights and the ites. They're polyatomic ions. They all will have oxygen in them. If you go back, and I don't have it open, periodic table, anything that ends in 8 or ite has an oxygen in it. That's what it tells you. Acetate, oxygen. Benzoate, oxygen. Borate, carbonate. Carbide is kind of useless. Peroxide, persulfide don't. You can go through. The only one that has oxygen that isn't an 8 or an ite is hydroxide, because that name goes back significantly further than those. Hydrogen sulfide. Thiocyanate. I guess that's the one that doesn't. I've never put HSCN on a test or an exam or something. I'm going to have to go for that. If it has oxygen in it, it's going to be an 8 or an ite, which tells us it's a polyatomic. So that means we need to go to the periodic table for the name. So HNO3, well, this has got 1, 2, 3 atoms. NO3 is nitrate. So if it's got an oxygen in it, we don't worry about the prefix. We're going to take a nite and change the 8 to ic. And HNO3 is nitric acid in its concentrated form. It's really fun. If you get it on your hands, it turns them. It oxidizes your skin and turns it yellow. It's a strong oxidizer, and we're generally not allowed to have a lot of it in schools because it's not unsafe, but if you don't know what you're doing, it can be ridiculously dangerous. Myself and Mrs. Parley would know what we were doing. I've used it plenty. It doesn't really bother me. Not that I've used it in a while, but it's just an acid. So nitric acid comes from nitrate. If it's an ite, we're going to change it from Ate goes to ick. Ite goes to us. So HNO2 in the same vein comes from nitrite. We're going to change the ite to OUS and then call it an acid. So HNO3 is nitric acid. HNO2 is nitrous acid. So I have a handful over here, which that's weird. That wasn't here earlier. That was over there. I love Smart Notebook. I'm going to drag these down below so I can kind of get a little bit more space. So I have 6 acids to name. There's only like so many of these, so if you actually take the time and go through the examples, half of them are going to be on part of the questions. HF. F is fluoride. So that means we want to put hydro, fluor. We're going to change the I to ic. It's hydrofluoric acid. That stuff, dangerous, not safe. To my knowledge, actually, I don't even know if the lab still exists. When I was in school, there's only one lab in New Brunswick that would ever use that because it's very dangerous. You have to buy your own specific spill kit. The thing from Breaking Bad, if I think there's an episode where they dissolve the body in hydrofluoric acid, yeah, it doesn't work. Hydrofluoric acid can melt your bones, but it doesn't dissolve a body. I just can't stop myself putting random bits of stuff in there. H3P is phosphide. So this is one hydrophosphoric acid. Technically, these both should have, all of these should have aqueous. We just assume when we're talking about acids, we're doing that. So I've got 4 more, all of which are polyatomic ions. SO4 is sulfate. 8, we don't use a prefix. Sulfuric. The sulfur and the phosphorus, for whatever reason, you kind of add letters back in. It's not phosphic acid or sulfic acid. It's phosphoric acid or sulfuric acid. I don't know why. I wish I had a better answer. SO3 is sulfite. Sulfurous. Sulfuric acid in its concentrated form was probably the most dangerous acid that they'll let us have in schools. It's very strong, very corrosive, will burn your skin. Not good. Sorry, but again, with the right knowledge, they're not dangerous. That's the only one I'd put gloves on for. But so the last 2 here, CN. This is one of the cyanide. Even though it's a polyatomic ion, it ends in ide. So hydrocyanic acid, if it's dissolved in water, that's what happens. That's the cyanide that will kill you. And CrO4. CrO4 is chromate. So chromate becomes chromic. That is also it's a strong acid. It's an oxidizer. It's actually a nice orangish red color. You can use it to clean just about anything. But again, not so spectacular. Ides, hydroic, ates, ic, ites, us, acid. They all end in acid. If you do a test or exam or something down the road or review questions for Chemistry 12 or whatnot, and you forget acid at the end, the word acid at the end of an acid, if it was me, I would straight up mark it wrong because an acid needs to have the word acid at the end. Writing formulas for an acid is fundamentally the same thing as writing formulas for an ionic compound. We will generally put hydrogen first. There's a couple cases where I don't, but for us, if we do, hydrogen is always first. It's always H with a plus one. So we add however many plus ones we need to cancel the charge out. We figure out what anion we need based on the name. If it starts with hydro, it's going to be an ide, and vice versa. So hydriodic acid is how you would say that. It's spelt that way, but it's a hydriodic acid. Hydroiodic means we want iodide, which is I with a minus 1. Well, if it's got a negative 1 charge and hydrogen is plus 1, therefore we need HI. You don't need the aqueous, but excuse me, that's a very strong acid. If you have a solution of it and you shake it, it can actually explode. But I've never actually dealt with it. Acetic acid, there's no hydro, so acetate, which is, if you look at your thing, CH3COO minus. So if you put, it's minus 1, so it's H. You're also going to see it sometimes written, and if we were in class, I would forget and write it like that, because if we did a structural diagram, whoops, C, H, 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 double bonded O with an O. This O, it's written CH3COOH because we've got a C with 3 H's, a C with 2 O's, and then where the H plus goes is tacked on that furthest oxygen. So you will often see, if you did something and write it like this for me, it's like, okay, whatever. Any of these things that have something COOH, it's that oxygen there that's negative, so that's where we technically put the hydrogen. So if you look at a bottle of acetic acid in terms of chemistry, that's the formula you're going to get. A lot of you have this in your house. Vinegar, it's a great thing. I used it this weekend to clean a shower head because we have hard water. When you get hard water, you have mineral buildup. Acetic acid, it will dissolve different minerals and make taps flow. You can use it to clean all sorts of things. It's got that smell. Some people put it on French fries. I don't understand why. A couple more. That summary is more for tomorrow. Carbonic acid comes from carbonate, which is CO3 minus 2. Well, if it's got minus 2, we need 2 hydrogens, H2CO3, fundamentally unstable in the atmosphere, but whatever. Okay, phosphorus acid. Why would I write PHOS? pH comes from phosphite, which is PO3, 3 minus. There's 3 of them. So that's H3PO3. Hydrobromic. Hydro means, and ic means it comes from bromide. Well, if it's bromide, we go to the periodic table and find out that's Br minus 1. So that's HBr. That's naming acids in a nutshell. This stuff at the bottom is general, like the whole thing that we've done. So your practice is the next page, I'm pretty sure, which is in there, is names and formulas. Well, hey, I just did that one. I did that one. I did that one somewhere. I did that one. I've done that one. This is a foolish way of writing acetate. I don't know. I don't think your periodic table has it like that. I hate it when it's written C2H acetate C12H3O2. I hate it when it's written C2H3O2, but again, I'm too stupid to actually rename things. So yeah, tomorrow I'll go over that and we'll talk about the kind of grand scheme of naming everything. And there's this little bit. There's a flow chart. And then there's practice 7 and 8. And I don't think I actually have it in here. But the last 2 pages of that naming package are totally optional if you're a nerd and really want to try. You can try those. That's 200 names and 200 formulas. I'll give you some strategies on how to go through that quicker tomorrow. Yeah, tomorrow. What am I? I don't need the calculator. We're going to need the calculator soon. What's this conversation? Oh, I'm glad Bailey's good. Didn't notice that. It doesn't pop up. Are there any questions?
No.
I asked that. I don't know why it scared the bejesus out of me, but it did. Sorry. I, I have problems. So that's acids. We'll talk about naming. I'll either, I mean, I don't know if people prefer me to upload the answers before or go through them tomorrow. Um, it doesn't really make a lot of difference to me. Um, we'll talk about naming the bulk of them, and then I'll probably put up another small assignment that will be kind of, it will be most likely the naming page of the test that I use, which is name some ionic compounds, name some molecular compounds, name some acids, and then here's, I don't know if it's 10 or 12 that are a mixture and you have to identify it. I check, can you name an ionic compound if you know it's an ionic compound? Can you name an acid if you know it's an acid? Can you name, but you need to be able to ultimately to make this like where you need to get to is can you look at a compound and say, hey, this is an whatever, or an or a, and write the proper name. And that's kind of what practice 7 and 8 are. If you're comfortable with these, you can start working on those already. Um, and then we'll start talking about some calculations. After naming, we need to do the mole, which we're going to look at molar mass and mole conversions. There's a couple things that we're just going to leave out because we don't have time, and we'll come back to a few things if we have some time. We need to do equations. We need to do stoichiometry. Those are the things that you really need, the basic things. If you miss some theory before grade 12, theory you can read and pick up, but um, naming and stoichiometry and that is really important. Um, so that's kind of my plan going forward. If there's no questions, I will sign off and talk to you all tomorrow.
Thank you.
You're welcome. Bye.